Hello everyone. Today we begin an exciting journey beneath the Earth's surface. For centuries, humans have explored the lithosphere, hydrosphere, and atmosphere. But what lies deep inside our planet remains a mystery. Let's explore how scientists, using indirect evidence like earthquakes and volcanic lava, study Earth's interior. Let us first learn about temperature beneath the Earth's surface. As we go deeper inside the Earth, the temperature increases. For every 32 meters we descend, the temperature rises by 1 degree Celsius. At 48 kilometers depth, it can reach 1200 degrees Celsius to 2000 degrees Celsius. And at the core, it may go beyond 4000 degrees Celsius. That's hotter than molten lava. Next is pressure. The deeper you go, the greater the pressure. At 2500 kilometers depth, pressure equals about 1 million atmospheres. That's nearly 3.5 million atmospheres at the Earth's core. Scientists use this pressure to study the Earth's surface. Now, let's talk about density. The weight per unit volume. Earth's average density is 5.5. The Sial layer, made of silica and aluminium, has a density of 2.7, while the Sima layer, rich in silica and magnesium, is 2.95. At the core, it can be as high as 16. Based on seismic studies, Earth is made up of three main layers: the crust, the mantle, and the core. Earthquakes and volcanoes help scientists understand this structure. Let's now look at each of these layers closely. The crust, or lithosphere, is the outermost layer, ranging from 6 to 48 kilometers thickness. It's made of two parts, Sial and Sima. The Sial layer is mostly continental and granitic, while Sima lies below it and is mostly basaltic. Sial flows on the heavier Sima. Let's compare Sial and Sima. Sial is made of silicon and aluminium, is lighter and found mostly in continents. It is discontinuous, meaning it's not found under oceans. Sima, made of silicon and magnesium, is heavier and continuous, forming the oceanic crust. We studied the Earth's internal structure, crust, mantle, and core, and how scientists use seismic waves, temperature, pressure, and density to understand it. With that in mind, discuss: how do seismic waves help scientists determine the composition and state, solid or molten, of the Earth's inner layers without direct observation? Share your thoughts among yourselves. The crust has sedimentary rocks on the top, though they are not found everywhere. Below them are granitic and basaltic rocks. These vary in thickness from just 3.2 kilometers to about 32 kilometers in folded mountains. The Moho discontinuity marks the contact between the crust and mantle. The mantle, also called the Pendolite shell, lies below the crust and is about 2,900 kilometers thick. It's divided into two parts: upper mantle, asthenosphere, and lower mantle, mesosphere. It contains magnesium, iron silicates, and sulfides. The upper mantle is partially molten, while the lower is solid and rigid. The core, or barosphere, starts at 2,900 kilometers depth. It's divided into the outer core and inner core. The outer core is molten with a temperature of about 2700 degrees Celsius. The inner core, made of nickel and iron, Nephi. is solid due to immense pressure, almost 4,000 degrees Celsius in temperature. Radioactive minerals like uranium and thorium found in Earth's upper layers generate a lot of heat. These minerals are more abundant up to 100 kilometers in depth and are formed in smaller quantities below that. They contribute significantly to the Earth's internal heat. Do you know seismic waves change speed and direction when passing through different layers of the Earth? This behavior, known as refraction, helps scientists map the boundaries between the crust, mantle, and core. For example, S waves cannot travel through the liquid outer core, providing strong evidence that this layer is molten. Let us revise what we have learned so far. Hello everyone. Today we begin
Layers of the Earth. This module includes Introduction, Source of Information, Earth's surface, Layers of the Earth, Earth as a magnet, and recapitulation. Introduction. What do you know about the internal structure of the Earth? You may think of Earth as a solid structure as it appears. But in fact, Earth's crust is floating on a semi-liquid layer of molten rock. Introduction. What do you know about the internal structure of the Earth? You may think of Earth as a solid structure as it appears. But in fact, Earth's crust is floating on a semi-liquid layer of molten rocks. Let us get to know more about the different layers of Earth through this animation.